In this video, we will take a closer look at how to communicate a robot with a CNC machine. Currently, there is no communication standard or convention that all CNC and robot manufacturers follow. Therefore, it is not possible to provide a solution that works for all cases. Despite this, we will discuss the most common strategies used in the industry today. There are two main ways of communicating a robot to a CNC machine, either by having an Ethernet-based communication such as Ethernet IP or Profinet, or by using discrete digital input and output signals. Selecting one over the other will depend on the features available on the robot and on the CNC machine. Ethernet-based communications provide vast possibilities to receive feedback and add robustness to the application, but require having or purchasing the appropriate communication boards. Some CNC machine brands also offer robot interfacing boards or add-ons that simplify the communication between the CNC and robot. These add-ons only work with some specific machine types and robot brands, making it important to verify compatibility before starting the integration process. The second and most common strategy to communicate a robot to a CNC machine is to use discrete digital input and output signals. This approach works with most CNC machines and might be the only option to communicate to old or legacy CNC machines. On this guide, we will mainly focus on this type of communication. Industrial robots have many communication options that can be easily used to integrate with other machines and devices. Most questions usually arise on the CNC side, so let's take a closer look into that. CNC machines have many options to interface with mechanisms such as probes, pumps, clamping devices, doors, and more by using miscellaneous or M-code instructions that change the state of different relays. The total number of M-code relays available depend on the machine brand, type, and on the features installed. Some machines will have M-code relays readily available to interface with a robot, while for others, I/O expansion boards will need to be purchased and installed. Before trying to integrate a robot to the CNC, it is important to make sure that the CNC machine is ready to be automated. Some machines already have everything needed to be loaded and unloaded by the robot, but in case that the CNC needs some updates or improvements, it is important to address those as early as possible in the process, as CNC machine components could have long lead times. The first and most important component to reliably automate a CNC machine is having an automatic clamping device, such as a vise or chuck. It is most likely that a lathe CNC machine already has an automatic chuck, but an automatic vise is not so common on milling CNC machines. Something that is usually overlooked, but important to consider, is that the vise or chuck will need to be actuated while the CNC door is open and the robot is inside of it. Keep in mind that, as a safety precaution, when the CNC door is open, the CNC program will not be capable of running unless some brand-specific safety features are implemented to the machine. Not all CNC machines officially support this, and it usually involves adding extra safety boards, devices, or procedures. The common approach for the robot to actuate the vise or chuck is to connect the robot signals in parallel to the clamping devices using relays. For the chuck, the parallel connection can be done at the foot pedal, and for the vise, on the switch or electro valve. These parallel connections will ensure that the clamping devices can be actuated by both the operator and the robot when the door is open. To ensure the accuracy and robustness of the cell, it is important to precisely align the workpiece with the clamping device. The slightest misalignment could cause the robot to stop or introduce errors when machining the part. It is also recommended that the workpiece is always being held by either the robot gripper or the clamping device. When the robot is loading a part, it should signal the machine to close the clamping device before opening the gripper. When unloading the machine, the robot should close the gripper before signaling the clamping device to open. The clamping device should have sensors for when it is fully open and fully closed. There are two strategies to open the CNC door for the robot. The first one is to use the robotic arm to open and close a manual door in a similar fashion to how an operator would do it. This approach has three main drawbacks. It considerably increases the cycle time. Most doors require a high force to start moving them, and this force could be higher than the robot can apply. And finally, it increases the complexity of the robot program. The second and recommended strategy to open the door is to implement an automatic door opener. Having an automatic door is a small investment relative to the price of the machine and the robot that greatly optimizes the application's cycle time. When using auto doors, it is also recommended to have proximity sensors to ensure that the door is fully open before the robot tries to enter the machine. For the CNC machine to call the robot to perform a task, such as loading or unloading a workpiece, an M-code relay connected to the robot should be used. When the robot finishes loading and moves outside the CNC, it needs to tell the machine to start the process. There are usually 3 common strategies for doing that. The first one is for the robot to press the cycle start push button on the CNC's control panel. The second option is to connect a robot signal to a machine's input. And third, and most common strategy, is to use a relay to connect a robot signal in parallel to the machine's cycle start button. This allows for the button to be used as normal by the operator or for the robot to emulate a button press to start cycle. As a final note, remember that relays need to be used between the robot and machine signals. Shown is a simplified diagram of the cycle start connection. After seeing what is required to successfully automate a CNC, let's highlight the recommended signals to reliably run a robotic CNC machine tending application. More signals could be added, but it all comes down to the needs of the process and how much feedback is required. It is also possible to automate a milling CNC machine tending application by only using 2 signals. Here, the robot places the part and exits the machine, and then when the CNC receives the cycle start signal, it closes the vise. Keep in mind that having only 2 signals will most likely not work on a lathe CNC machine, as the part could fall if the robot opens the gripper before the chuck grabs the part.